Retrieval gets evidence in the door, but that is only half the job. In RAG, the last mile is deciding what context reaches the model, how it is ordered, and how much can fit. In this section, we'll package evidence so answers are accurate, focused, and efficient. So far, we've connected traditional machine learning to the context challenges of LLMs, then introduced RAG as a way to retrieve fresh, relevant knowledge at runtime. Now we'll make that retrieved context usable inside the prompt. After that, we'll compare runtime context with fine-tuning. Retrieved chunks are candidate evidence, not a finished answer. If the prompt is vague, the model may miss useful context, blend in unsupported claims, or sound certain when it should qualify. Since the context window is limited, every chunk needs a reason to be there. Strong RAG prompts organize evidence, set expectations, and balance relevance, clarity, brevity, and grounding, so the answer stays useful and trustworthy. A strong RAG prompt works because each part has a clear job. Instructions define behavior and constraints. Retrieved context supplies the evidence, ideally with source labels for traceability. The user question defines the task. Output requirements shape the response. Format, citations, uncertainty, and when to say, "I don't know." Together, these parts turn a messy prompt into a more reliable answer pipeline. One useful way to think about a RAG prompt is as a contract. It separates retrieved context from the user question, then tells the model which source of truth to follow. The key instruction is simple. Answer from the provided context only. If the answer is missing, say so clearly instead of guessing. When accuracy matters, require source IDs or citations, so responses are more consistent, traceable, and safe across different questions. Good RAG prompting means setting operating rules, not just asking a question. Specify whether the model can use outside knowledge or must rely only on retrieved content. Define what to do when evidence is missing, ambiguous, or contradictory. Then control the response format, such as a summary, steps, table, or bullets. If the answer must be auditable, require citations. These constraints reduce unsupported guesses and make outputs more predictable. Think of the context window as a shared workspace. Instructions, retrieved chunks, the user question, chat history, and the answer all compete for room. More documents can help when they are relevant, but weak or redundant context adds noise and can pull the model off task. Reserve space for the answer itself, especially when you need a longer, structured, or cited response. Retrieved context is most useful when the model can tell what each piece is, where it came from, and whether it applies. Instead of pasting raw chunks together, wrap each chunk with labels such as source, title, date, section, version, or permissions. Use clear separators so boundaries do not blur. This helps the model compare sources, prefer fresher or authorized information, and avoid mixing unrelated details. Retrieval gives us candidates, not the final context set. Context selection narrows those candidates to the chunks most likely to answer the user's question. Start with top K results, then filter for true relevance, permissions, freshness, product version, and document type. Remove duplicates or overlapping chunks. The goal is not maximum context. It is the cleanest, most useful context the model can reason over. Vector search is usually the fast first pass. It brings back a broad set of candidates, but the order can be noisy, and a useful chunk may sit below weaker matches. Re-ranking adds a more careful relevance check between the user question and each candidate chunk. Then only the strongest chunks in the best order go into the prompt. This matters because the model often relies most on the context it sees first. Context order is another design choice. For focused questions, place the strongest evidence early so the model anchors on what matters. For timelines, policy changes, or release notes, chronological order helps preserve causality. When chunks cover different themes, group related material to reduce topic switching. Keep behavior rules before retrieved context so instructions remain clear. There is no universal best order, so test arrangements against real queries and measure answer quality. Context overflow is not just a hard limit problem. It begins when retrieved chunks, chat history, and instructions crowd out the space needed for the answer. Estimate tokens before the call and reserve a clear output budget. If the prompt is too large, avoid blind truncation. Cutting the wrong section can remove the fact that matters most. Prefer smarter reduction. Filter irrelevant chunks, summarize history, or split the task into smaller requests. When retrieval returns too much, the model has to separate signal from clutter. Start by filtering out stale, low quality, unauthorized, or weakly relevant material. Chunk carefully so each piece is focused, but still carries enough surrounding meaning. For long sources, summarize to reduce volume while checking that key facts survive. Finally, control duplication, because repeated near matches can crowd out better evidence and lead to less focused answers. Before shipping a RAG prompt, treat it like an engineering artifact. Keep instructions, retrieved context, user question, and required output format clearly separated. Then test 4 cases: answerable, unanswerable, ambiguous, and conflicting context. Check whether citations truly support the answer, whether claims are grounded, and whether latency is acceptable. If results miss the bar, adjust retrieval, re-ranking, chunk formatting, and wording together, then retest. You've now completed the core RAG arc: retrieve relevant context, shape it for the prompt, and guide the model toward grounded answers. The main takeaway is that better RAG is not more context. It is the right context, clearly separated and structured. Next, we'll compare this runtime approach with fine-tuning.